system is fed off of panel LLF1, circuit 41. It comes and feeds this plug here through the bypass. Basically here on the front, you have battery life. It's 100% right now because it's on, it's just charging. If in the case of a power failure, this thing will beep every 30 seconds. And when it gets down to the last 2 minutes of battery life, it'll just constantly beep at you. And there's a load indicator right here telling how much load is being drawn from it. Seeing as how it's just the flare panel out there, it's something like a ½ amp being drawn, so it doesn't even register on this. So you should have a pretty good amount of battery lifetime on it in case of an outage. In the case that you need to either work on the AC line or you want to take the UPS off the line, it's this disconnect switch right here. If you want to take it off of AC line power, you switch it to make sure the switch is on UPS, and then the disconnect line, switch it over to off, and that takes the line voltage off of it, but it's still running on battery power. In the case you want to take the UPS off, you leave the AC line on and switch it over to line, and then you can turn the power off, and it's just running off the dirty power, the 120 volt power. And usually when you want to do that is when you want to change the batteries. This one is capable of hot swapping. You can leave it on and take the batteries out. The front opens right here, the bezel opens up, and the batteries just yank right out, whatever you're comfortable with. I would suggest just turning it off and then pulling it, and then usually the batteries last anywhere from 5 to 10 years, depending on how much usage it is, if they will use it or not, and that's basically it. And then the UPS feeds this panel right here, and right now you're only using one circuit, which is over there. So there is expansion, capable expansion on the UPS system if you guys need be. Basically, depends on the load. There's almost no load on here. I mean, it could be anywhere from 2 to 8 hours, depending on the load on the thing. It could be anywhere from 2 to 8 hours, yeah. Like I said, there's no load on it, so I'm gonna guess it's probably gonna at least last you 2 hours, I'll say, at least. And the way you can tell is, you know, if you have power outage and it's been like an hour or so, come over here and look at this battery indicator and see how far it's come down. And you get a pretty good idea how much battery life you're gonna have left. Any other questions?
And then the most important part is the operation that the panel operates in. It's got 3 modes of operation: local control, where everything, local manual, where you got to push the buttons to start the flare manually. It has local auto, where one of the pressure switches over at the flare starts and stops the panel. Then you have remote auto, where the DCS system starts and stops the panel. So I'll start with the description of the panel components. The PLC at the top here is a typical Allen Bradley compact Logix that you guys have on many of your other smaller panels at any of the IUA sites. It actually does not do the controls of the flare. All the relay logic is actually controlling the flare. The PLC is only taking data and sending it to SCADA and looking at alarms and sending them to SCADA. So, and in remote auto, it just takes the start command from the DCS and starts and stops the flare. But there's no abundance of logic in the PLC. It's mostly just for data exchange. The FireEye controller right here, it is the main brain of this whole panel. So if you notice the difference, you guys have seen the old panel compared to the new one, it looks way more complex and more components, but really the controller is identical, and it's really what's in control. It's what recognizes if there's a flame and decides to start or stop the flare based on whether there's a flame present. It has control over the gas valve. And so all the different modes of operation are telling this FireEye, I want to start. The FireEye decides if it's safe to start or not. That's all it does. This is just the Ethernet switch with fiber on it. That's connected to the DCS system, so this panel can talk to the DCS. The fiber patch panel is just to terminate the fiber, nothing else. This jumper is just terminated in here. DC power supply, it just powers all the 24 volt components in the panel. That's all it's for. The whole myriad of relays There's only a few different types of relays in here. They're all the same. You know, we use 10 of each type or whatever it may be. There's only a few timers in here. They're mostly for alarms. In other words, if you have a high temp alarm or a low temp alarm, the delay time before it goes to the DCS is through those timers. They've already been adjusted and tested, so we're not going to change them. But in the book, it tells you what approximately what the delays are for each time, which we'll go through later. This temporary panel on the side, you should ignore. It's not going to be there when we are finished with the 30-day test. It's allowing us to switch between the old panel and the new panel right now. So eventually it'll be removed after this panel has gone through the 30-day functional test. The controllers here, this temperature controller is the one that's modulating the damper up on top of the flare and also generates the low temperature alarm. This temperature controller here is looking also at the flare temperature. Both of them can see what the temperature of the flare is. This generates the high temperature and the high temperature alarm. And this display here is just a window to see the fire eye. So if there's a fault on the fire eye or a flame fail, you'll see it on this display. If you want to see how many flame failures there's been, you can scroll through this button here, but you guys will probably never have the door open anyway, but that's what it's for. It's probably more for the maintenance technicians than the operators, but that's all it is so you can see without having to see the controller in the background. We'll go to the front of the panel. Excuse me. It's got a air conditioner on the side here, maintaining I believe 80 degrees or something. It also maintains heat. It's a dual climate control, so it keeps it warm in the winter and cool in the summer, but it doesn't like try to attempt to keep it freezing, so that way it won't run 24/7. So it I think it's set for 80 degrees or something like that. The components inside are capable of like 140 degrees Fahrenheit, so it's just to keep the thing from getting super hot. The light switch on the side here controls the light up here. It has a on-off auto, so it's an LED, so it doesn't look bright now, but it lights up fairly well in the night. I've been here in early morning and it does well. It has off for whatever if you want to shut it off and maintain it. And then in auto, there's a photo cell on it to turn it on and off every night. Now you can still view the temperature controllers with the window on the door, and so you don't have to open the door to see what the live, like the flare temperature is displayed on both of these controllers. The power on light is just telling you it's actually on right now. It doesn't show up very well in the day. That's just saying the control power to the panel is on. Local manual mode, local auto mode, and remote auto mode is directly related to this switch here. So whichever mode you put this in is the mode of the panel is in. So if you see nothing, it could just be a light bulb. These are all push to test, so you can push the light in to see if it's the light bulb's functioning. However, 3 of the buttons, this one, and this one, are actual buttons and lights. So if you push it, it's actually going to cause something to happen. So you want to maybe think about it before you push one of those, unless you know what you're pressing, which we'll get into in a minute. And these are all alarm lights that are obviously red. That's for pilot fuel alarm, which is the natural gas system, low temperature in the stack, high temperature, and high. I'll go over what each of those do when we talk about each mode of operation. Flame fail is on right now because this panel doesn't have control over the flare. The old panel does right now. So it tried to start and failed, and we just leave it failed for the moment. But if we switch to the controls to this new panel, then the flame failure will be active. So it's only on now because it tried to start the last time we switched to the old panel. There's three 3 modes of operation. In the mode it's in now, local manual, it's 100% manual. You would put it in this position if you were coming out here and manually starting the flare. I don't know why. You would know better than me. If you're testing something, you want to see if the flare starts, you're trying to get rid of gas manually for some reason, you're sucking the digester gas pressure lower than it would normally be. Yeah, it's beyond my expertise to know why you'd put it in local manual, but it's purely manual. When you put it in local manual, the light will light up, tell you it's in local manual. You would push this reset button that says push to reset, limits normal. The flame fail goes away. If you wanted to start now everything's good. If you see any red lights, you know, you're not ready to start. And if this green light isn't on, you're not ready to start. That's why it says, if you ignore the push to reset, it's limits normal. So the green means everything's okay. This light means which mode you're in. This light means power's on, which you can't see too well in the daylight. But if you wanted to start the flare right now, you would push this pilot on button first, and this step-by-step description is in the training manual. And it says hold for 10 seconds. We added that nomenclature because if you push the button, the pilot light would come on, and you would assume that the pilot has been proven at that point. But there really is no indicator on the door that tells you the pilot's proven. It takes about 4 seconds for the safeguard flame relay, the red box inside, before it recognizes there's a flame present. So we added the hold for 10 seconds. It doesn't hurt to hold it longer. It might be good in 5 or 6, but just in case, you push the pilot on, you hold it for 10 seconds, then you let go, you'll hear the pilot running, and it'll be running. Now, it's up to Scott if we actually want to run the flare manually right now so you can actually see it happen. Then, after that's done, you'll see that the pilot's on. You push the main valve on. You just hold it for a couple of seconds. You'll watch the main valve open, and then the flare will operate. In this mode, local manual, it'll continue to run indefinitely. There's nothing to stop it. So you got to be sure you want to run it in manual, and then you got to be sure someone is watching the gas pressure, either locally on the local gauges or the pressure transmitter, or someone on the DCS is watching, because I guess you can suck your lid in here. I'm unaware of the mechanics of everything, but I'm just told you can't suck this thing down too far, or all kinds of bad things are going to happen. So, Scott,
Yep.
Did you want to start this thing?
Yeah, we can have somebody step up and simulate the startup.
You want to shut that one off? You can actually do it?
Yeah.
If this fails, does it automatically reset like the other controller does?
Only in remote auto.
But it does do that.
It will do it, yes.
Controlling this one already now?
No, good. So he shut the existing flare off. There's an existing flare, new flare on here. Again, this is not going to be here when you guys actually run this, but for the next 30 days it will be. So we're going to switch it to new flare. Now this panel is in control, and the old panel is off.
Debbie, you want to come up and do it?
So we'll go ahead and start it manually. Hold that button and hold it for about 10 seconds. Nothing's happening. Oh, there it goes. Keep holding it.
Oh, keep holding it?
Yeah, it's okay.
You gotta do it over?
Doesn't matter.
So the intent, the reason why you're holding it is you're just waiting long enough that the pilot light can come on and that flame can light.
Right, just keep holding it.
That's the natural gas kicking on there. Flare, pilot's on now.
Now it's probably proven by now. You can go ahead and let go. Now it stays. So you can see it's no big deal if you hold it too short.
Can I open this?
The pilot will go out. You just have to hold it again.
So that you know, that's just opening your M3 main valve.
Now,
So
so
you're
you held main valve on. The main valve is open.
How long do I
Now
have
you
to
let go.
Okay.
That's it. So right now,
Would you get this alarm every time?
no, this low temperature alarm is slightly misleading. If the temperature of the flare is low when it's running, the light will come on, but the alarm has not been sent to SCADA yet. It has to run. There's a timer in there. I believe it's TR1, but the manual tells you which one. It's 14 minutes long, which is we don't have it set for 14. We actually tested it with Jose. It's set around 13 minutes. It's that way it fails before the SC AQMD. The maximum time you can have less than 1400 degrees on the flare is 14 minutes. So we set the low temperature alarm where it'll actually shut down at about 13 minutes. So, but the light is tied directly to the temperature output. So as soon as the temperature is below 1400 and the flare is running, you'll see the alarm, but as you see it went away because the temperature got above 1400. Even in manual mode, the controller on the left is always modulating the damper up there. So even on the existing panel, this temperature controller is always running that damper. And the reason why is when we switched it over, we couldn't have two dampers, so as soon as we got this one up and running, it's always operating the damper. The set point you can see on the screen is 1500 degrees. Ideally it's supposed to be 1450, but it was occasionally dropping under 14 and making the light come on. Even though it was only for a couple minutes, Jose chose to bump it up to 1500. But you guys can make your own decisions if you want to change it slightly. But the perfect temperature set point by the engineers' standards was 1450. It's actually set at 15 right now. So
you want to talk about how to turn this off?
Yeah, in other words, in order to stop it, now that it's running in local manual mode, is to switch it to local auto or remote auto. It's the only way you can stop it. If you got desperate, you could turn the power off, but you shouldn't do that because it'd take time to reboot the machine and everything. Should I go ahead and kill it?
Yeah.
Now the reason it didn't shut off in local auto is that the capsa photohelic pressure switch was still in calling for the flare to run in local auto. So I went to remote auto. Well, now you can see we must still have pressure.
Yeah, it's firing up in auto.
So now it's firing up in remote auto because the DCS is calling for it because the pressure's still above the stop set point. So as you can see, the flare is going to try to start in whatever mode you put it in as long as the gas pressure is calling for it. Now, are there any questions about local manual mode? It's pretty straightforward, but you just got to know to start the pilot first, hold it enough time where the pilot's proven. If you let go and it goes out, it's no big deal, just push it again. After it's up and running, turn the main valve on. For as long as you feel comfortable that the main valve's open, you can hear it, then let go, and then it's going to run indefinitely until you shut it off.
Does the pilot gas run all the time in local manual?
No, it does not.
When does it shut off?
The pilot will shut off approximately 4 minutes after running. So now that we stopped it and restarted it, that timer is going to restart. And that's another thing we tested with Jose. We've run this thing a bunch of times, and they decided after 4 minutes we'll have it shut off. There is a timer to make it more or less. The old system, the pilot ran indefinitely, but on this one, after 4 minutes, the pilot, you'll see this light. If we wait 4 minutes, which we guess we can, this pilot light will go out and it'll be running on 100% digester gas. And then when the DCS calls it off because the pressure's down to whatever shut-off point is, the main valve will close and it'll go off and it'll sit here with just the green light and the remote auto light on.
So 4 minutes is the timer on the pilot for all modes?
Correct. It's the same timer no matter what.
Steve, we talked about the importance, since we're still talking about local manual, of the only time that flare is going to shut off in local manual is when you guys physically switch to a different mode of operation. There's no pressure switches or anything that are going to shut that off. It's going to continue to suck gas.
Now, if there's some reason you don't want the flare to run, like I switched it to remote auto, it shut down, and then the DCS called for it again. If you get it to stop, you can put it back in local manual, and it won't start again because you have to manually reinitiate it. So if there's for some reason you want the pressure to build, you put it to local manual, because local manual is kind of an off. Like if it's running right now and you wanted to stop it, the best way is local manual, because it's not going to start until you make it start. So local manual is kind of your off switch, but also if it's running in local manual, you got to go to one of the other modes to shut it off, and then you can flip it back to local manual if you want. Any questions about local manual mode?
Justin, you're on call tonight? You want to just try starting it up real quick on local manual?
Are you going to run this overnight?
No, I probably won't put it on until manual says, which realistically wouldn't be until tomorrow.
Go ahead and local manual. Just It should go. You hold it. Go to the pilot on and just hold it long enough.
Well, I counted 10 seconds.
Oh, well,
So on this one,
if you don't
you'll
see it
hear
light up,
the
don't even
initial
bother.
startup sequences, you'll hear the natural gas kick on, and then the pilot comes on. So that's natural gas. No, you still gotta wait. Because initially that's natural gas. You haven't lit it yet.
Now when you start hearing it light.
You can still give it a couple seconds.
Maybe. So it has to actually be lit for 5 seconds.
So like,
It's
right
probably
now.
now.
You can hear that the flame went on. So now you open up your M3 valve. So that's just open up your main gas header valve, and you should hear your flare kick on.
there you go.
Okay. And then again, just I mean, I know we just said it. The importance is that's going to continue to run until you tell it to stop.
You get to shut it off then?
Let it run for a little bit.
After 30 days, they're going to take this out and get rid of it.
Does anybody else want to do it in local manual just to see how long that delay period and the wait is? Are we good?
I guess to be safe, you should hold it and hold the pilot on button 10 seconds after you see the light, because there's a delay on the fire eye before it.
Yeah, that's what I was telling Sean, and I know you don't want to probably change that thing again from because it had nothing to 10, but maybe it might be nice to say hold for 15 or 20 seconds. That would take all the thinking out of it.
Okay. So in remote auto, it's going to start again by the DCS. Wait, flame fail.
That'll reset itself.
I hope so.
Too many fingers in the pot.
God.
It's going to go. Interesting.
Do the failure alarms on this panel still relay into the LCP inside the digester building, or is that been removed? Because prior you would get a flare failure inside the digester building on that LCP that you had to acknowledge and reset.
On the annunciator panel, or
Yes.
I don't know. That's something we would have to look at. Everything's now is going to be controlled in SCADA, so I would assume not, but we'll look into that.
That's my question, is because I know we're trying to go away from those annunciators, but I just don't know.
The only reason why I might say yeah, when we walked in there initially for the training, it was going off on flame fail. So they still might be getting that signal, but that might be the transition of old new panel.
Right.
Now this flare failure in the panel here, how many times have it failed before since it launched?
That's a good question. It's 3 times. So now it failed twice, but I think it tried twice the first time it failed. So you may or may not have just now got a flame failure to the DCS. But as you can see, it does restart when it gets a flame failure. Why it got that one, I don't know. You saw we started it several times manually. Everything seemed to be fine, but it happens once in a while. Usually when we were playing with it, every 10th or 15th time we started the flare, we'd get a flame fail. So it still does happen, but you can see it retries itself and recovers. And there's going to be a counter, I think you have it now at the DCS, where it tells you how many fails there's been. I don't know if you guys operators are the ones that keep track of that. Okay, well, I don't know if it's the same counter you had on the old one or if Sammy made a new one, but I know after 3 retries you're going to get the alarm, and the number of retries is always counting up, and it resets at 10,000 in case that's relevant. But that's when I reset it. That's what Jeff Trowgett told me to set it at.
Where's that 3 retries come from as far as like if you wanted to get changed to 5?
It's in the program.
In yours or in
Yeah.
ours?
No, it's in here.
Oh, so
You'd have to have one of the programmers remote into the panel.
Sammy has access to this program right now?
You should.
Okay.
Yeah, it's on the network. I mean,
Yeah, I'm just curious. I don't know. They might.
yeah, no, I think he can. And it's just a counter. I just have, if the counter is greater than 3, then it lets the DCS alarm go through. So it can be changed to whatever you want if you think that's too quick.
So after 3, it keeps trying?
It tries indefinitely, but it sends the alarm to you guys after 3.
So there's no time period after like so many failures. It's gonna say, wait, I'm gonna have to wait a half hour before I try again. There's
No, it just keeps trying.
Which that logic mimics exactly what we had on the old panel to start.
At least I was told that's what it was. In other words, Sammy or Jeff told me what they wanted it to do, and they said they were copying what the old one does. So I don't have it wait for anything. It just keeps retrying, and sends the alarm after 3 tries. And the time between retries can be changed also, Pat. Whatever, if you guys find it's not working the way it is, you can lengthen or shorten anything you want in the program. It's not that difficult now that it's there. You want to try local auto?
Yeah. Let's talk about the capsule photohelic first, because Gary's got to pull some gaps.
Okay, so you want to go over there now? Okay. Can we move the camera? Okay. The next mode of operation that the panel can run in is local auto. Local auto is virtually identical to local manual, except this capsule photohelic pressure switch is tied upstream of the main M3 valve, so it can see the digester pressure, gas pressure, ahead of all this stuff. When it reaches the needle on the right, which is adjustable with the thumb screw, which Scott's been adjusting where he wants it exactly right now, the flare will start. It will run for at least, there's a time delay in the panel that keeps it running for a minimum of like 1.5 minutes, something like that, to keep it from short cycling. And then when the pressure falls to the low needle, it'll shut off. So the operation, the components, the time delays, everything is identical, including the alarms, as it was in local manual, except this switch has total control over the operation of the flare. So it starts on the high, when the actual pressure hits the high needle, it stops when the actual pressure hits the low needle. Any questions about this switch or what its function is?
That's only supposed to function when we have a SCADA interruption or a loss of SCADA?
It's good you brought that up. It's the sole function in local auto when you do it on purpose. There's a second feature which he just brought up. If you're in remote auto, which is the normal operation, and we get a communication fail between this panel and the DCS, and it's proven, in other words, we wait a couple of minutes before it acts, there's a relay inside the panel that will force the panel to local auto because it no longer can see what the live pressure is. So then the panel will work off of this. So even though the switch is in the remote auto position on the door, the local auto light will come on. Now the remote auto light will also be on. So if you guys are ever out here and you see remote auto and local auto, you know there's been a comm fail, which you should get an alarm anyway, and that it's in the quasi local auto mode. In other words, it's running off this switch. If you see the local auto light on, period, it's running off this switch. If you see them both on, remote auto and local auto, you know there was a comm fail and it's forced over to local auto mode. This switch is completely ignored in every other mode though. So if you're in local manual, it doesn't matter what this switch does. If you're in remote auto, it doesn't matter what this switch does. It's totally out of the picture. Only in local auto or that forced local auto, when there's a comm fail, does this switch run the flare. That's its sole function. That's all it's here for. It does nothing else besides that. It doesn't generate alarms. It doesn't do anything. Any other questions about this switch and what its purpose is? As long as I'm here, I might as well show you all the other instruments here and their function, and then I'll go back and just finish anything else I want to talk about, remote auto and alarms and so forth. Down here is a new natural gas pilot system that Pat actually installed because it wasn't in the contract, but the old pilot system was looking pretty scary, so they put a all stainless natural gas pilot system in, and right now it's paralleled with the old one, so that way either panel can run their own pilot system right now. Eventually the old one will be taken out and it'll just be this one. But on that pilot system are 2 solenoids, which the new control panel controls. Every time the pilot tries to light, it opens those solenoids, lets the natural gas in. Then the igniter, this is existing. We put a new enclosure in, a new used enclosure. You guys provided this enclosure. We took the old igniter that used to be sitting here on the side. It's now in this box, but it's still the old igniter. It was not part of our scope. but we relocated it as a change order. And the used to be like the ignition wire, which looks like a spark plug wire, used to be laying on the ground. It's now in this conduit here. Excuse me. So when the pilot tries to start, the solenoid's open and the natural gas is let into the igniter starts it. There's two switches, this one and this one. There's a pressure switch low and a pressure switch high. If the natural gas, when the pilot tries to start, these two pressure switches are monitored, and the natural gas pressure has to be between those two. If it's lower than the low switch or higher than the high switch, it'll set off an alarm in the panel, and the very bottom left warning light says pilot fuel alarm. So whether it goes high or low, it'll turn on the common pilot fuel alarm and send it to the DCS. And of course the flare isn't going to run either, so that's actually a pretty critical one, because it can retry all at once. If there's a pilot alarm, it's never going to start. So that's the purpose of these two switches, and they operate no matter what mode you're in. Over here, these two are tied to the downstream digester gas. It's called burner pressure because it's right before the burner. This one here on the left, PIT1, is a pressure transmitter. All it's doing is sending the live digester gas pressure at the burner, which is lower than coming in, to the DCS system. It has no local display or no local function. It's just there so the DCS guys can see the burner pressure. However, the other switch on the far right does have a function. It's tied to the same pressure, and it's a switch, and what it does is when the flare first starts up, the controller looks at the lower thermocouple. You see there's two thermocouples on the side. One's a few feet higher than the other. Those are both brand new. One of them we installed per contract, and then later they decided we should have both of them new, so we put two new ones in. So when the control panel starts, it looks at the lower thermocouple. When this pressure switch gets above set point, which is around 5 inches of water column, it activates a relay in the panel which switches and ignores the bottom thermocouple and connects the controller to the top thermocouple. So the controller on this side of the panel, which is just the high and the high temperature, it's always looking at the upper thermocouple. And so it always reads what the upper thermocouple says. The controller on that side, which is the one that operates the damper and sets off the low temperature, it's the one that gets switched. So when the flare's off, you'll notice that the thermocouple over there, the temperature might be, let's just say it's 800 degrees. The upper might be 830 or something. They'll differ quite a bit. But as soon as the flare starts running and this pressure switch activates that switching relay in there, both controllers will look at the upper thermocouple, and you'll notice that the pressures are almost identical within a degree or two of each other. Then it doesn't apply, I don't think, to your process, but if the pressure was to go down far enough where this switch deactivated, the controller would try to maintain temperature based on the lower thermocouple instead of the upper. But that's usually not the case with you guys. You guys run it so high, you start at 12 inches and stop at 11 or 10 and a half or whatever. It hasn't even switched to this. So you guys are looking at the upper thermocouple almost all the time. Only on startup is it looking at the bottom. So that's the purpose of this switch. The air damper up top, that motor that you see in the explosion-proof box, it's modulating the damper. It's the exact same motor that used to be sitting up there, except it's in an explosion-proof box now, like it should be. And it acts a little different than the old one. The old one was like a power on, power off one that could only open or close. This one's a true analog one, and its position is controlled by the temperature controller on the left in there. It's always modulating even when the flare's off. So the flare's off, it's trying to make it hotter, it closes the damper. If the flare heats up, it's trying to maintain 1500 degrees. And it also has 120 volts, which is powered by the panel. So not only does it have the control signal wired to it, it's also powered by the panel. Am I missing any instruments over here? I believe that's everything we provided. The two control valves, one of which doesn't even work, they are now controlled by the new panel, even right now. So they're normally held open. DCS has the ability to close them if they so choose, but I'm told it doesn't happen very often. But the new panel has control over those valves, can open and close them from the DCS, but there is no manual control. You can't walk up to the panel and do anything to them. It's all DCS controlled. Any questions about any instrument over here that I may not have covered?
I had a question. After your 30-day test, is that panel slated to be removed? And if it is, it's going to be removed by you guys?
That's a good question.
Obviously, it's not intrinsically safe. You know, I mean, we're going through all the expense and, you know, for the igniter and the, air dampener.
Yeah, well, it's got to be removed because it's no longer going to have control over the flare. Whether or not we remove it, to be honest with you, I have to read the specifications and see if we're responsible to remove it or not. If we are, we're going to remove it. If we're not, you're going to remove it. But it's got to be removed because it's going to be dead weight at that point. Because once we remove that temporary panel in there, this panel is not going to have control over the flare anyway, and so it's going to be a museum article at that point.
And on that, when does the 30-day test start, or approximately?
Whenever you guys decide you want to start it. It's either going to start tomorrow, or if somebody's scared about starting it on a Thursday, they might start it on Monday. It's kind of up to you, but I don't want to wait till after Monday. I want to get it going as soon as possible. But we've tested the flare to death. The panel, it appears to function properly. We might as well start putting it through its paces.
Yeah, the initial driver, we wanted to give you guys all the training on a Wednesday, and then Manuel's going to make the ultimate call of when do we start the 30-day test. As long as you guys all feel comfortable with the training and know that when you're on call, what you need to do, who your point of contacts are if there is an issue, then we'll be ready to go. Start Friday.
Any other questions about any of the instruments here on the skid? Okay, let's go back to the panel for one last description of the remote auto mode, and maybe I'll tell you what I know about the alarms and when the DCS is going to get the alarms and so forth. Okay. Just a few more things about remote auto mode, which is where this thing should be 99% of the time, assuming nothing goes wrong or you're not maintaining something. In remote auto mode, these are the only two lights you should see on. Any other red light obviously is some sort of alarm. You have to come and see what it is. Like I told you before, sometimes you'll see a high temperature alarm or a low temperature alarm come on while the flare is running. It doesn't mean it's going to get the alarm to the DCS. As soon as the temperature dips below 1400, you'll see the low temperature, but if it recovers, it'll go away. And the timer that was starting, the 13-minute-ish timer that was starting to send the alarm to DCS will reset again. So it has to stay on for 13 minutes straight on low temp before the alarm goes to the DCS.
If the alarm never clears, will it shut down the unit?
No. For a low temperature alarm, it does not shut down the flare, but it will send you guys an alarm. For a high temperature alarm, it will not shut down the flare, but it'll send you an alarm. The high temperature, which is set at 2000 degrees, the flare will shut down and lock out and you're done. You have to come out here, see why the thing got up to 2000 degrees. Maybe the damper is stuck shut, I would guess, and you have to do something about it. As long as the temperature comes back down, you'll be able to clear it. You won't be able to clear it if it's still up above 2000, but if the temperature comes down and cools down, you'll be able to clear it. The flare will probably restart. Then now that you're watching, maybe you'll notice the damper's not opening or whatever the reason was that it got hot. Going back to the high temperature alarm, it's only set for about 2 minutes. So and right now it's set for about 1800 degrees. So if it gets above 1800 for 2 minutes, it'll send an alarm to the DCS. What else? Flame failure, you already know it'll try to restart itself, even if it gets a flame failure like right now. If you got a flame failure right now, the flare will immediately stop, shut down, couple seconds will go by, you'll see the flame fail light go out, and it'll try to restart again and go through its normal, you know, retry. Scott wanted me to include that we have our contact information. When this, as soon as the 30 days starts, Morrow Meadows is obligated to be here within 4 hours of a problem. So we're gonna have Jason's number. I don't know if you knew that. My number, and then Brian Rick, some of you know who he is. He's the electrician that installed most of this stuff. His number is on the contact list. So even if it's after hours, if you can't figure out what it is, you can call us and we'll respond to help you try to resolve what the problem is. But I think I'm correct in saying that technically when the 30 days starts, you own the panel and you're in charge of operating it and so forth. But if there's something you can't figure out, we're obligated to respond within 4 hours.
Is the pressure regulator still the same as it was with the old?
You would have to ask Scott that.
There's been no adjustment.
We haven't changed it, that's for sure.
You mean the diaphragm valve?
Yeah.
At least on when they get the other digest stuff online.
Do the controllers have, are they able to set like a, you know, with a transmitter you have a high or low burnout, they call it? Like if you lost the thermocouple, would it go high or?
I believe we'll cover that in the instrument training later,
Okay.
but I'm pretty sure we might have to try it. If you lose the thermocouple signal to the controller, it's going to say open, but I don't know what action it's going to take because we've taken it off when we were testing, but we weren't actually running the flare at the time. I don't think anything's going to happen because we have no other outputs from the controller besides the high alarms, the low alarms, and the analog out to drive the damper. So I don't believe anything's going to happen. You're just going to see the alarm on the controller. Any other questions about anything about the flare, this panel, or what we've installed? Feel free to ask me whatever you
When
want.
we're going through our 30-day test, we're going to be running off this panel. If for some reason I come out in the middle of the night and there's an issue, how do I go back to my old panel?
Good, thank you. We're running on this panel right now, right? You get called in the middle of the night, something's wrong, and you can't seem to get this thing going for whatever reason. I don't know if operators are allowed to, but you open the door. If somebody has the appropriate PPE, whatever your guys' rules are, although there is no voltage over 120 in this panel, so there's not a severe arc flash like from 480, but you follow whatever your guys' rules are. The side panel says existing flare, has a 2-position switch, existing flare, new flare. You would switch it to existing flare and then go over to your flare, put it in auto or manual or whatever you normally do with the old panel, and you have a second shot of getting the stack running again. But you got to ask your supervisor or whatever if you should call a maintenance guy to open the door or whatever. That's your business. But that's what you got to do to get it back to the old flare. Don't forget, because we've done this while we were testing, is we switched it to new flare like it is now, and we left the old flare in auto, and then the thing was going crazy. Old flare was trying to start the panel and couldn't. This flare was starting it. We couldn't tell which was going on, and it turned into a big confusion. So if you have it in existing flare, that's fine, but if you put it, let's say you get it running that night and you figure out what the problem is, if you want to put it back to the new panel, that's fine. Make sure you turn the old panel back to off. Otherwise they're both going to try to start it, and it could be dangerous because the pilot gas is still controlled by each panel. So this panel could be not running, the old panel could sit there and keep introducing natural gas into the flare, and then when we actually try to start it, it might go poof or something. You would know better than me, but just make sure you know which flare you're running and that your panel is off if you're running this flare. Any other questions?
As a result of this and our trying to upgrade to Allen Bradley and all that stuff, is there a new Foxborough display for the flare?
Good question. There is a new Foxborough display that's out. It's actually out there. So it's under. Let me see exactly where it's under.
The question was, is there a new Foxborough display for the new flare panel? And there is. And Scott will show you where it is on the SCADA, on the DCS.
Solids and it's titled Jasper 1.
Okay. Who did that work?
Sammy.
Sammy did it?
So Sammy's kind of the gatekeeper for that. He knows all the ins and outs.
And we've tested all these signals and alarms with Sammy here to the new DCS, so whatever you see should be valid information.
So in the event of a power outage, this is connected to the emergency generator?
Forgive me, I'm not done. Yes, thank you. I left a very important part out because I wasn't following my book. That's the 3 modes of operation. There's one more emergency mode. You saw the UPS earlier today. That's the only load on that UPS right now is this panel. Even though it's tied to a whole UPS panel, this is the sole load on that UPS. So if power dies and the generator doesn't come up, or whatever you guys, you know better than me what the backup power is around here, the UPS will keep this panel running, and it controls everything in this panel. The only thing that the UPS is not tied to is the air conditioner and like the convenience receptacle and the light or something in the panel. Non-necessary loads are not on UPS. Everything else, including the Maxon valves, the inlet valves, is. So when power goes down to the plant and even the generator dies, the UPS will keep running the flare until it's dead. But let's say it's the super end of the world, the generator, whatever your backup generator doesn't start, and the UPS goes dead. You guys run out here with the emergency. By the way, if utility power fails, that's an alarm to the DCS. You guys come out here with a portable generator. Let's say that's your source of power. Down here is a male receptacle. So you just plug an extension cord into the generator, plug the other end into here, or whatever your backup source is, I don't know. You turn this control power here. Well, don't plug in the plug yet to be safe. Turn this power to off. The panel will go dead. Then start up your generator, plug in the plug down at the bottom. Then turn this power back to on. Now you might need a maintenance guy here at this point, which I'm sure everybody be here by now if the power's that gone. In here it says emergency power off and on. You turn that switch to on. At that point, you should see everything light up again, except for the air, the light, and unnecessary items. Now you have control over the flare via the generator, and then you can run it in local manual. I think in my step-by-step procedure, which you should look at in the book, we put it in local manual first, just to make sure it's not going to start or do something weird. Then you turn the power to off. Then you plug in the generator. Then you turn the power to the left, emergency power. Then you open the door, turn the emergency power from off to on. Everything will light up again. You might have to wait a couple minutes till everything comes up to life. Then you can start it in the local manual or put it in local auto and let the capsule photohelic run the flare. And so as long as that generator's running and you're running again, you're great, and you keep doing that way. I also have, you should do the exact opposite when you shut it off. In other words, turn the aux power back to off, turn this power here back to off, probably put it in local manual so it doesn't fire up unexpectedly, then disconnect your power, then turn this back to power on. This is after you've determined that all the power is back to normal, and then you'll be back on normal power again. Thank you for bringing that up. I left out a whole section.
There is a portable generator and air compressor inside the digestive building now, designated just for this area.
Okay, for the sake of the tape, there's a portable generator in the boiler room. And an extension cord just for that purpose. So it'll be nearby, you can drag it out here and hook it up.
The air compressor, we put a fitting on there, so all you have to do is pull that hose that's on there right now that has the little blower on there and take that off and plug it right into the air compressor, and it will feed into there and can run the valve.
Okay, for sake of the video, there's also a backup for the air, because if the plant air goes down, you guys, I guess, have a portable air compressor, and you can tie into the main valve, so because it operates off of air. And I'm told the inlet valves are going to be air too, so you're going to have to, same thing with that in the future. Any other questions? Thank you all for being here.
Everybody signed in.
If you have any questions, you guys Pat or your construction management has our numbers, or our numbers are in here. You can call us with any questions or get a hold of Scott. Thank you very much.
Thank you.